So today I would like to show you how you can make the machine learn which mouse movements lead to which button being clicked. So first of all, this is the demo, and I'm going to initialize the data. That means deleting all previous training data. I'm resetting a model. And most of the output down here, you can disregard. I'm just having the development tools open to give you a little bit more transparency. And you already see some TensorFlow.js taking place down here. But the first thing that we have to do is to collect data. And this data consists of the mouse movements that you do before you click on a button. And you see a lot of stuff is going on down here because for the sake of this demo, I'm not making myself clicking on all these buttons, but for the sake of, for the duration of this demonstration, I'm pretending then that when I hover over a button, it is as good as clicked. So this makes it a little bit easier to collect some data because machine learning doesn't work without any data. And while I'm doing this, I'm trying to move to these buttons here in some fashions that I would actually use to click on these buttons. And you see it's pretty hard for me to talk and move the mouse at the same time. It has always been the case with me, but you can see we've collected 120 data sets already, and let's have something like maybe 150. And for something like machine learning, this is not at all a lot of data. We have 3 categories: first one, second one, third one, and we have only around 50 samples per category. This is almost nothing. Now, let's say this is enough data, and this might even be more data than you would typically have on the standard UI. So now we can start the training. And it prepares some data sets now. It converts them into the format that TensorFlow.js requires, and training begins to start. And for now, I'm closing this here, so we get a little bit more space to look at what's going on. And what's interesting is the curve on the lower right. I'm zooming in a little bit because that's what's really interesting. You see an orange and a blue curve here, and they describe the accuracy of the model. Let's look at the blue curve first. So what it says over time, over the transition of the progression of the training, the blue curve gets a little bit higher. We are a little bit above 1.6, maybe we're around 1.7. And this means 70% of the data that I created and that I'm using to train our machine learning model is predicted correctly. That means 70% of these mouse movements led to clicking a button were predicted accurately. But much more important is the orange line, which means some of the data we didn't use for the training, we only use for validating how good the model is. And this is about the same, which is very good because it might mean that the model generalizes very well to real world data. So the training has been done already. That's quite fast. 200 iterations. You could have seen that this was all running in the background, and this visualization, it was just for as a courtesy to us. It wouldn't have been necessary. So I'm zooming back out again, and I'm closing the visor for a second. And I can always open it up again because it might show more interesting things, but maybe we show some more interesting things now. We can show some evaluation of the training process. And looking at the upper part of the image here, you see so-called confusion matrix. And on the y-axis, you see the real buttons. And on the x-axis, you see the predicted buttons. So, for example, this stuff up here, where you see the 93. I'm zooming in a little bit. So from the training data that we had, we knew that a certain sequence of mouse movements led to clicking the left button. And after the training of the model predicted correctly for 93 of those movements. But sometimes, even though it was the left button that's being clicked, it predicted the middle button, which is not very surprising because the middle button is pretty close to the left button. So not very surprising. So this looks good. This looks reasonable. And then also, even though it was the left button that's being clicked, the model predicted only 4 of them to be the right button, which also makes sense because the right button is pretty far away from the left button. Now, for the middle button, you see most of the middle button clicks were predicted correctly, but some of them were mistaken for left and some of them have been mistaken for right, which also makes sense because they're both close to the middle button. And then same for the right button. Most of them have been predicted correctly. Some have been mistaken for middle button, but only very few for the left button. And scrolling down a little bit, you see accuracy broken down to each individual button. And you can see that the accuracy for the middle button is definitely smaller, only 65%, but for both of the other ones, it's around 80%, which is pretty good for a sample size like this. And you can also see that for all the buttons, we had similar amounts of samples. So not too bad. You might wonder why there are so many samples, even though we only had around 180 original samples. It's because in the process of preparing all this, we created subpaths. That's a little bit advanced, but never mind, more or less. So let's try this out. I'm hiding this thing again. You could save that model to local storage. In this case, it's not actually local storage, it's IndexedDB. And I could download it, save it on my local disk. I could load it from some remote address. Or I can just use it right now. So I can toggle the prediction. That means now the model is in effect, and what you see down in the console is the probabilities for each of the buttons. So in this case, it thinks that the right button should be the one that I'm going to click. But for this demo, I disabled the prediction unless I pass this button here. So it thinks this is going to be the right button. And now if I go here, it thinks it's going to be the left button. And we didn't have a lot of training data, so the middle button, it's never too sure about the middle button if I move like this. But the right button, it knows for sure. The middle button, maybe had more training data on the middle button when I came from down here. And it seems to be working okay if I'm below that. And you need to understand that the only thing that the model can learn is the actual movements that I did while training. Maybe that's what I did. I don't even quite remember. So, but then if I go here, I have the left button, middle button, right button. And if I'm in this area, it's pretty sure that I'm going to click on the right button. In this area, it's pretty sure I'm going to click on the left button. And this seems like it thinks if I'm on the move here to the middle button, it also seems to be pretty accurate, which for a machine learning person, this is very surprising because we only had very little data. And it still seems to be able to properly generalize, which is a pretty good result, actually. So with that, have a look at the model, because it does a little bit of work to obtain that robustness using batch normalization and also a little bit of dropout, and because it's very simple all by itself. Okay, that's it for today. See you and bye-bye.